Hello, Algebra 3 students. We are going to begin with Chapter 2 today, and it's going to be about equations and inequalities. These are the 6 sections that we will be covering. We'll be covering all 6 of them, and then we'll be having a chapter test over all this. So, this lesson is going to be 2.1. We're going to be solving some linear equations, and then next few chapters deal with application problems, and then the last 2 deal with linear inequalities, and then some absolute value equations. So solving linear equations. So it starts us out here with some basic things that we should know from our previous algebra classes, like putting together like terms. What are like terms and what are unlike terms? And it shows us here in this area that these are like terms, so negative 3x, 8x, and negative 1/3 x. So notice that all of these values of x are to this same power. This is understood to be 1. That's what makes it a like term. All of these down here are to the power of 2. So those are like terms, meaning you can add together or subtract these terms. When they're unlike, we cannot put them together. So these unlike terms over here, we cannot add them together or subtract them. Okay. Combining like terms, it says determine which terms are like terms, add or subtract the coefficients of those like terms, multiply the number found in step 2 by the common variables. Okay, so example here down below. We have 5a plus 7a. Well, you just put together the coefficients, 5 plus 7, that's 12, and then you just tag that a on the end there. So 12 times a. And that's it. Distributive property. Distributing property means we're going to distribute this term to both of these across the set of parentheses. So as you see in this example here, we multiplied the 3 to the x and then the 3 to the 5 to get 3x plus 15. And then remember, these two terms that we end up getting here, the 3x plus 5, we cannot add those together because they are not like terms. Okay? So this is where we would stop at in our problem solving. Alright, simplifying an expression. Alright, most of the time in our equations or our expressions that we look at in this section and many other sections later on, we use the distributive property first, and then we combine like terms. That's all this slide is telling us. Alright, so linear equations. This is what a linear equation is. A linear equation in one variable is an equation that can be written in the form ax plus b equals c, where a, b, and c are real numbers. And then the value of a right here that's attached to our x, it can't be 0. Otherwise, it's not a linear equation. The solutions to an equation is the number that, when substituted for the variable, can make the equation a true statement. So after we are asked to solve for the solution, meaning we find what is x equal to, the solution, what we should end up with is an x value that we can plug back into here and end up with a true statement, and you'll see that in our examples here in just a bit. So here's our first example. It is asking us if x equal to -1 is the solution to our equation that we have here. Okay, so like I said in the previous slide, what we're going to do to figure out if this is a solution is plug in -1 in for all of our x values that we have and see if we have a true statement. Okay, so I'm just going to go ahead, plug away. And whenever you do plug in a negative value, I like to put in parentheses, especially when the x values are being multiplied. Not necessarily here, but whenever they're being multiplied by a number. So here we go. -3 Plug in that negative 1 for the x, minus 3 equals our negative 4 times our negative 1 plus 3 minus 5, again, times negative 1. And over here on this side, if we use our order of operations and combine together these two terms, we're going to end up with a negative 3 times a negative 4, which equals a positive 12. Let's see if the other side is equal to the same thing. So, of negative 4 times a negative 1, well, that gives us a positive 4. Then I'm just going to drop down that 3. And then we have, basically here we have a negative 5. See, negative 5 times a negative 1. That becomes positive. So we have plus 5. Add that all up, we end up with a positive 12. So it is true that x equals negative 1 is the solution for this equation, because this statement here is true when you plug in negative 1. Okay, next example. Well, first of all, in this example, it's using the addition property of equality. What the addition property of equality states is that in our equation, we are able to add or subtract numbers from both sides of the equation. And that is how we're going to end up solving for some of our equations for our variables. So here in this example, I am just going to say, well, we can add 4 to both sides of this equation, and what we end up with is x on this side. The 4's cancel out, and it's equal to negative 6. So there's our solution. And then this property, in this example that we'll be using, is called the multiplication property of equality. It also encompasses the division property of equality. We can multiply or divide numbers from both sides of the equation in order to solve our equation for our variable. So, in this example here, what I'm going to do is say let's divide 12 on both sides in order to get y by itself. So it does cancel out on this side, and we end up y equals 15 over 12, which reduces to 5 over 4, and we're done. Alright, so using those properties, all of those properties that we just discussed, we're going to solve this equation. Like I said before, many times we start out with the distributive property. So let's do it. Distributive property, multiply the 3 out across the set of parentheses. This is what we're going to get. We're going to get a 12 minus 3x. Then bring down the 5x equals 9. Now combine our like terms. We have a set of like terms right here, the negative 3x plus 5x. So combine those together to get a positive 2x. So now, in order to solve for x, we got to isolate x on one side of the equation. And in order to do that, we got to subtract our 12 on both sides. So when we do that, we get 2x on this side of the equation equals negative 3. Now, using that division property, we can divide both sides by 2, and we get x all by itself is equal to negative 3 over 2. And that is our solution. In this example, what we're going to be doing is finding the solution set. You learned about sets in the last chapter, so we're going to express our solutions as sets. And then we're also going to indicate whether the equation is a conditional or an identity or a contradiction, and I'll explain those as we go through. So I'll explain real quickly what a conditional is. A conditional is when our variable, such as x equals some number. That's what we're used to seeing, actually. So say it's x equal to some value, like 1. That is what a conditional equation ends up being. An identity, what happens in an identity is we have the equation, something like, we'll end up with 3x plus 1 is equal to 3x plus 1. Well, both sides are equal to each other. Everything is going to end up canceling out. We're going to end up equal with 0 equals 0. Well, that's a true statement, which means this is an identity. And in an identity, what our solution set is going to end up being is all real numbers. And that's what we're going to state is all real numbers. And then for a contradiction, well, whenever we solve our equation, at the end, you'll end up actually canceling out x altogether and end up with something like 0 equals negative 1. This is not a true statement, which is why it's called a contradiction. So that is how we'll figure out what is a contradiction. And then the solution set for the contradiction is what we call the empty set. And if y'all remember how to draw an empty set, it's just a set with nothing inside it, or you can state the empty set with this symbol right here. Okay, so let's do this example. First thing, do the distributive property. Let's do this on both sides of the equation. Let's do this and this one. I'm going to say 7 plus 3x minus 6 plus 8x, and that equals 6x plus 6 plus 2x minus 9. Alright, now that we've distributed everything, let's combine like terms. And when we do that on both sides of the equation, I'm going to combine the 3x and the 8x to get my 11x. And then this right here and this right here are like terms, so combine them. 7 minus 6 gives me plus 1. Let's do the other side of the equation. Combine like terms over here. We get 8x. And then these two are like terms, so combine them together to get, let's see, negative 3. Now, get all of our x's on one side of the equation and all the other numbers on the other side. So I'm going to subtract 8x on both sides of the equation to get, let's see, that's 3. Plus 1 equals negative 3. And then add or subtract this 1 on both sides. Come over here. And that ends up giving me a 3x equals a negative 4. Now, still trying to isolate that x, divide both sides by 3, and we end up with x equals negative 4/3. And we are done. Except for answering whether this is an equation, this equation is conditional, identity, or contradiction. Well, like I said, if we end up with an x value or a variable equaling some number, it's a conditional equation. So for this one, it's conditional. And our solution set for this, how we would write it is just in a set notation here, write our number that we end up x equals the negative 4/3. And that's it. So there's our solution set right here. And then it's a conditional equation. Let's try another one. Alright, so again, find the solution set and tell whether it's conditional, identity, or contradiction. Alright, so distributive property. Both sides of the equation. So we get 6x minus 6 equals, and then a negative 6 plus a 3x, and plus 3x. Okay, let's combine like terms on that right side of the equation. There's nothing to combine on this left side. So we end up with, well, that gives us 6x and minus 6. So again, like I said before, whenever we have both sides equaling each other, so we have a 6x minus 6 and a 6x minus 6, you can stop right here. You don't have to cancel anything out. You can just say that this is an identity. So it's an identity, and our solution set for this equation is going to be all real numbers. Okay, so last example. Okay, we've covered conditional and identity, so you can guess what this is going to be, but let's solve it out anyway. So we're going to use the distributive property twice on this side of the equation, and this is what we're going to get: 3x plus 9 minus 8x. And remember, a negative 4 minus 7, that's going to become positive 28. And then it's equal to negative 5x plus 2 on this other side. All right, if we combine our like terms, this is what we're going to get. Combine those two and these two, get a negative 5x plus 37 equals a negative 5x plus 2. Well, if we try to isolate our x on both sides of this equation, well, we end up adding a 5x on this side, 5x on this side. It cancels out our x values. So we end up getting 37 equals 2, which this is not a true statement. 37 does not equal 2. That is why it's called a contradiction. And our solution set for this is an empty set. And that is it for this section. We are done. So I'll see you in class. Bye, everybody.